Morning students. So as you all know about, we are going to discuss physics of 10th class. So as we already discussed two chapters till now about physics in the past when we are not done with the quarantine. So let me introduce you the two chapters. One is reflection of light on curved surfaces, and second one is chemical equations. So let me take your point here. Already we just discussed a reflection of light on curved surfaces. So I know this is already almost 1.5 months we were not at all discussed about these chapters again. I think you have really forgot of these what we already learned in these chapters. So now I just want to recollect what we already learned in the past classes, so that will be helping for you to learn in the future, where you are going to learn about remaining chapters, where I need to start the third chapter as acid and bases with addition of salts. So this class is totally regarding about revision of the first chapter and the second chapter. In the session 1, we were going to discuss only these two parameters. So let me come with the reflection. So what we learned in the reflection? Reflection is the point where the light which is falling from a distance will be hit to a mirror and reflected back here. As we already learned about this in your 8th class. But here we were going to learn about a curved surfaces. As you already know what is meant by a curved surfaces. The curved surfaces are derived into two parameters. One is a concave mirror and another one is convex. So in the 8th class you just learned only about a plane mirrors. So this you are learning about curved mirrors. So difference between a plane mirror and a curved mirror. See, for example, this is mirror which is plane and opaque object. Let's imagine a light ray is falling here and it will be moves out. In the sense of it we call as an incident and here we call as a reflection. So I and R. So the angle here making is angle I and angle here making is angle R. Right? So as a plane mirror is there here, we can directly say that angle I is equal to angle R for these plane mirrors. But now coming to the curved mirrors, it cannot be said like that. Angle I is equal to angle R. Why? Because convex, concave, indent, they will be in a curved position. They will be in a simple and curved position. Let's take concave. Have you ever seen a cave, right? Cave in the sense of it will be in a closed part, like in that. So cave, it will be inside, and convex, which is outside. How can we know about where which is inside and where which is outside? Let's take a point here, concave here, concave. When we take a concave, in the sense the cave body and the line which is passing from the center of line, we know that this is called as a principal axis, as you already learned everyone about this principal axis. And here a light ray is passing through the curved mirror. So if it hits at one point, then it will be reflected back through the another point here. So the light ray which is hitting inside, that's why we call it is a concave. Which is outside, let's take it is a convex mirror and light ray is falling here. Outside, and light ray is hitting at one particular surfaces here, moving outside, and the light ray also moves out. Here, this is incidence and this is reflection. Here, it is incidence and it will be a reflection. See, so the difference comes here. Concave is the line which is passing parallel to this one and hitting inside to the mirror and moving out, we call it is a concave one. And hitting outside of the surface and moving out is called as a convex. To be understanding clearly, we will be arranging the mirror point like this, so that inside will be a mirror and in here outside will be the mirror. So due to itself only, the incidence and the reflections are gonna take place. So you already known about it, the parameters, the line which is passing all the reflections between the point we call as a focal point. And the double of the focal point we call it is a center of curvature. It's nothing but the line which is passing with the normal lines here. Simply. And the line which is passing with the one is a tangent. And the line point where exactly hitting the center point is called a pole, as you already known about that one. And the distance between the pole to the focal point is called a focal length. And the distance from pole to the center of is called as a radius of curvature. Simple. Radius of curvature can be written as 2f. RC is equal to 2f. The same will be applicable to the convex also, not only a concave. Same, the convex will be having the same parameters as the line which is trace the points here is called a focal, and the line which is coming for the point for the normal is called a center of curvature, and the line which is passing from the center we call it is a pole, and the line which is moving here is called a principal axis. Whatever it may be, both the concave and the convexes are having the same priorities. There is nothing to be changed over here. Both have a same line and same length and same angles will be taking place here. But as according to we've seen here plane mirrors, these concave and convex mirrors do not have the same priority like having angle I is equal to angle R. Why? Because it's a curved one. So for that, here we derived 3 rules for these concave and the convex. What are these 3 rules? The line which is passing parallel to the principal axis reflected back through the focal point. Or else, second one, the line which is passing through the focal point, then reflected back parallel to the principal axis is the second one. In the third one, if a line is passing through center of curvature, reflected back through the same. So the reflection is common for all these points because it is a reflection of light on a curved surfaces. Here what is happening, when a light is passing parallel to the principal axis, they are reflected back to the focal point. In the same way, if you pass a light through the focal point, then it is reflected back parallel to the principal axis. There is nothing change occurs over there. But only a point is like when it is passing through the center of curvature, then the light will be no change. That will be the incident and that will be the reflection. So that's what these 3 rules indicates. What is use of these 3 rules? In the sense, in the diagrams where you have a running notes, just take out the running notes while I'm explaining here, you will be getting a clarity. There we just learned about what a point where reflections and refractions taking place and positions of an object. We already learned you. What is an object? Let's see, imagine, as you already see everything in the mirror. If a light passing directly onto the mirror, you cannot see your face there because the light is disturbs you on the point. In the same way, here we have some positions. Position in the sense of light which is passing to the one particular point and light which is not passing through the particular points here. So, we will take a point of light at a center of curvature. If a line is at after the center of curvature and on the center of curvature and beyond the center of curvature and on focal point, what will be the position of image formations? We already learned here. So this helps us to know about what position, what kind of reflection, what kind of positions that can be formed by using these concave and by the convex mirrors. And second point is here, why a positions are needed? See, we just want to find out what is the distance of one object and where is the image can be formed. To find out that, we just need to know where will be a incident point and where will be a reflection point will takes place in a particular situations. So using those particular situations, understanding those scenarios, we were trying to analyze the points where these reflections and refractions are to be forming in a situation of light ray incidences. So for that we are derived a formula called mirror formula. 1 by f is equal to 1 by u plus 1 by v. As we already discussed about this, what is f in the sense of focal point and u will be the object distance and v will be the image distance. So you can able to find using this. When the magnification starts, then we need to call m is equal to hi by h naught is equal to minus v by u. This will be a most prioritized situations to know about what is an object to be formation in each and every point. So you already aware of an Archimedes, the scientist who just blasted the ships by using the concave and the convex mirrors. So he used the same principle, using the same three rules. He just destroyed the total ships for his country whenever it's needed. So we can do by using this a rice cooker. As you already know, it's nothing but you can take a curved surface and make all the reflections to be forming at one particular point when there is a principal axis is there. Then all the reflections meet where the focal point will be having a more heat, which generates higher heat and makes the rice to be cooked very easily. Further, what you need to do? Nothing. You need to make the adjustment of all the lights to be falling at the same particular point itself. As you already seen a movie called Krish 3. As you already know about how the light rays are disturbed when the sunlight is forming. In the same way here, the light rays are made to be fall directly into the focal point. When the light ray is falling on the focal point, every point where the sunlight can be falling over there, then the heat generation will be more than everyone can able to understand the solar cooker, how it works. You don't wanna take it to a separate one. If you wanna try in the house, you can also try by using a light ray incidences. So children, this is about a total revision of the first chapter of reflection of light on a curved surfaces. Now I'll go with a revision of chemical equations.